Hello, welcome, and thank you for joining us today for the Embodied Carbon Network's 2019 webinar series. My name is Victoria Herrero Garcia. I am a whole building lifecycle analyst for a company based in Denver, Colorado called Ambient Energy. And I am very excited to be volunteering for the Embodied Carbon Network as the webinar coordinator. I will be moderating today's session. This is the fourth session of a six-part annual webinar series. We have several exciting speakers joining us today who will outline how reuse reduces carbon emissions, preserves natural and historic resources, and drives economic development. Please note that this webinar is being recorded and will be made publicly available by October 11th. Many of you joining today are already members of the Embodied Carbon Network. We do have guests in the audience who we invite to learn more and join the network. The Embodied Carbon Network is a communications and knowledge sharing platform that was launched by the Carbon Leadership Forum in January 2017. The network brings professionals working in or within the building sector together to share news and resources, engage in discussion, and develop educational content. The network has evolved into a vibrant, engaged global community. To date, we are over 630 professionals from across the building sector, academia, nonprofit, and government groups representing 166 cities from 22 countries across the world. We are brought together under a shared mission to eliminate embodied carbon emissions from the built environment in order to meet global greenhouse gas emission targets by 2050. The network comprises 10 subject-specific groups, which members can join for additional engagement around a topic related to embodied carbon. The Embodied Carbon Network is funded and managed by the Carbon Leadership Forum. The Carbon Leadership Forum is an industry academic collaborative based out of the University of Washington that carries out research, education, and outreach initiatives focused on embodied carbon emissions tracking and reduction. Thank you to our sponsors for supporting the Embodied Carbon Network and its annual webinar series. Again, today is the fourth session of a six-part series. Each topic is based off network-focused group topics. Network-focused group chairs have worked with their groups to identify the speakers and develop the curriculum for each session. Our goal is that each session will not only be useful to live participants, but also serve as free educational resources for anyone interested in learning more. Please feel free to share webinar recordings with your colleagues, professional networks, and students. Mention of trade names or commercial products does not constitute endorsement or recommendation for use. Please note the opinions, ideas, products, or data presented by the speakers in this session do not represent members of the Embodied Carbon Network or constitute endorsement by the network. Our goal is to introduce topics that could help participants think and talk about building industry strategies for reducing carbon emissions attributed to building materials. A few things to know before we kick off presentations. Presentations will be followed by a 15-minute Q&A session. Please submit your questions through the Zoom chat function. I will track and direct them to the appropriate speakers at the end of the session. If you are an AIA member and in need of educational credits, this course is eligible for live attendees to receive credit. Please email to info@embodiedcarbonnetwork.org your AIA member number, and full name. If you missed previous webinar series, please visit the embodiedcarbonnetwork.org/webinars to access session recordings. Stay tuned for more information on upcoming webinars. Save the date for session 5, happening on Friday, November 8th, and that will be the buildings group. And a reminder as well about the ECN quarterly call on October 25th at 9 a.m. Pacific time. And now I want you to get to know our presenters. The first one will be Miya Kitahara. She will be speaking about the big picture circular economy in the built environment. Next will be Joe Connell with why decon and reuse matter from a community development standpoint. We will have also Andrew Ellsworth talking about how reuse works from a commercial materials standpoint. And finally, we will end with Larry Strain, who is the chair of the reuse group, and he will be speaking about why reuse plus upgrade matters from a carbon standpoint. So with that said, we will move into Miya Kitahara. Miya Kitahara works at the works on stop waste, energy efficiency, built environment, and circular economy projects, and provides climate action planning support for Alameda County local governments. Stop Waste is a public agency in the Bay Area and a sponsor of the Carbon Leadership Forum. Miya has promoted the awareness of embodied carbon to local governments across California. She has over a decade of experience in local government sustainability across the Bay Area, serves on the West Coast Climate and Materials Management Forum leadership team, and holds an MBA in Sustainable Enterprise. Miya, are you with us?
Yes, can you hear me?
Yes, thank you.
Can you see my slide?
Yes, go
Perfect.
ahead. Thank
Great.
you.
Thank you. Good morning. Thank you, Victoria. As she said, I'm Miya Kitahara with Stop Waste, and I get to set the stage for my fellow panelists by talking about the big picture of circularity in the built environment, and with specifically a focus on the role of reuse within an overall circularity framework. So as Victoria said, Stop Waste is a local government agency here in Alameda County, California, and we've been exploring circularity as a way to effectively reduce waste going to landfill. But as we'll see, it's also a way to reduce embodied carbon. So, move my slides. Okay. In a linear economy of take, make, use, and waste, or where we're extracting materials, building with them, operating the buildings, and demolishing at end of life, there are carbon emissions all along the lifetime. When we recycle materials, we cut off the phases of demolishing downstream and extraction to some extent upstream. And here we see some avoided embodied carbon emissions. In circularity and generally materials management, we talk about higher and better use of materials, keeping them as intact and at their highest economic value as possible. So this means in this diagram, going inward on the concentric circles to repair and reuse. And when we repair or reuse a product without breaking it down into its basic material components for recycling, we see even greater avoided embodied carbon emissions because we avoid some of the production phase of the life cycle emissions. So there is a nexus between circular economy and embodied carbon. The solutions are not always compatible, but there is a lot of overlap. So I would encourage anyone that's interested in circular economy to really check out the Ellen MacArthur Foundation. They're a global leader, a thought leader in this, and we've been members of their Circular Economy 100 group for 3 years. Here's an example of a resource from the Circular Economy in Cities toolkit. And I'll be pointing out some of these drivers for change that are kind of creating the necessity for circular economy in the built environment as we go through some of these slides. So let's look at the transition from today's building material flow to what a more circular material flow might look like. So this is what we have today, basically. The large band across the bottom being mainly a linear throughput of materials, with the loops above representing an effort for C&D recycling and some building renovations that occur naturally. Increasing circularity in the built environment means creating more loops and making them thicker, putting more material through those loops. So at the material level, more efficient recycling or more effective recycling, and moving inward on the circles, disassembling parts for repurposing, refurbishing, modifying to use almost wholly intact and closer in is salvaging for direct reuse, and also placing a greater emphasis on building renovation and upgrades. Again, with the tighter loops resulting in greater embodied carbon savings by avoiding more processing, manufacturing, and transport. So we and our partners at ARUP produced a primer on circularity concepts geared towards local governments, which can also be a good, simple introduction for anyone interested in looking at circularity in the built environment. And in it, we looked at these varying scales at which materials can be reused or used more efficiently. And at each scale, we looked at strategies for A, making the most of what's already existing, already in place in the built environment, and B, for designing new construction. First, for material efficiency, which would also reduce upfront embodied carbon, and also for optimal chances at reuse at the building or part's end of life. This last point, designing for disassembly and a second or third life, does reduce embodied carbon, but in the future, potentially decades from now. So with our immediate focus on embodied carbon now, we're going to limit our conversation today to the first point, using what's existing already in place. The existing built environment contains billions, trillions of tons of materials in varying degrees of reusability. The lowest embodied carbon option would be to extract these components and parts in whole form, not demolishing it into rubble, and reusing them as intact as possible. So strategies at this scale include deconstruction. Here's a building at the Port of Oakland being deconstructed for its valuable wood beams, and using those salvaged materials, and then to a less valuable extent, ensuring that what can't be reused in whole is recycled. So Joe and Andrew will be talking about this scale of reuse today. And then keeping as many of those parts and components intact in the building and extending the life of those parts by reusing the whole building is the next scale of reuse. At the whole building level, getting the most out of existing buildings can include sharing and increasing occupancy rates of currently underutilized buildings. So some of these statistics we saw from the Ellen MacArthur Foundation report show that there is significant underutilization of existing buildings. And then taking those older buildings and retrofitting them and upgrading them to improve their performance, and also adaptive reuse of existing buildings if the programming of that space needs to change. So this is an example of an old noodle factory turned into affordable multifamily housing here in Oakland. And Larry will be talking about this scale, the building scale of reuse today. And finally, no building is an island, and especially local governments need to consider how all of the existing buildings and new construction serves the end goals of housing people and jobs at the community scale. And this awareness should also apply to developers and anyone who's really building in a community. How does the placement of individual buildings of what height, type, and building materials affect the overall community's carbon emissions, both operational and embodied carbon? So this is a question that we at Stop Waste are helping cities in the Bay Area start to ask, maybe not yet answer. We're doing this through an interactive planning charrette game. We'll be playing this at the Getting to Zero conference in Oakland on October 11th, and I'm happy to talk about that offline some more. But some common strategies that are already used to optimize the use of existing city infrastructure and the existing built environment into which a building is added are things like infill development, efficient use of spaces, smaller units, while being careful not to compromise quality of life or cater to a very small segment of demographics. So it's a little bit tricky and you need local government intervention there probably. but also in the single family space, the emergence and popularity of accessory dwelling units and subdividing larger homes into multiple units. So that's just to set the framework and stage in which all of the detailed kind of reused examples that the rest of the panelists will be speaking about. And here's a summary of the report that I mentioned that we invite you to use as you like, offer us feedback, but to get the conversation started. And I'll pass it along now. Thank you for allowing me to do that. And Victoria?
Yes, thank you
Yes.
very much, Mia. And we're going to introduce now to Joe Connell. Joe has been the executive director of the Build Reuse, formerly known as BMRA, which stands for Building Materials Reuse Association, since 2017. Being in the building trades since he was 15 and in reuse nonprofits for the last 20 years, he is a builder at heart. Since 2000, Joe has been a leader in the reuse industry, first in the Northwest, where he helped launch several local reuse groups in Portland, Oregon, and served on the City of Portland's Deconstruction Advisory Group to pass the nation's first deconstruction ordinance. Then nationally with Habitat for Humanity through his work on the National Restore Committee. Joe helped build the Portland Habitat Restores into one of the nation's top 5 restores in revenue and net profit. Since joining the BMRA, he has been revising and refocusing the organization to align build reuse with other industries in the sustainable materials management industry and continue to heighten the awareness of reuse and deconstruction. Hello, Joe.
Hi, thanks, Victoria.
Yeah.
Thanks for joining us, everybody. Nice to kind of meet you. Build reuse. And Mia's presentation was brilliant because it started pointing towards the reasons why we do this work in the first place. And it comes down to the communities and the people. The whole reason we have buildings is because of people. So my work and the work of Build Reuse and what excites me is the community level. And that's what I've been asked to talk about today. But I want to start by talking about where we're at with buildings and why it's relevant in our mind. According to Architecture 2030, we have a lot of buildings that are going to be coming down over the next 30, 40 years, 2/3 of them. So my big question there is, what about the other third? And what happens when we take these buildings down? We're also hearing that the global building stock is going to double in area by 2060. This is the equivalent of adding an entire New York City every month for 40 years. And I love this slide here because in my mind it represents quite a bit. This is New York City garbage dumps back in the day when all of the refuse from New York City was taken in barges out into the ocean and dumped. We've come a long way from that, but I remember it as a kid. I remember seeing these barges, and it was a horrific sight. And so we've come a long way. It's always a good reminder to me of one, where we've come from, and two, how much more we have to do. But my basic question here is, and I'm preaching to the choir here, is where will all of these materials come from? They're going to come from natural resources if they're not reused. There's an incredible amount of wealth in the material values within our buildings that are going to be coming down. If we destroy those materials, they go to waste, and we take new natural resources. The key there that I mentioned is the wealth in the present materials, and that's where the community aspect in my mind comes in, is because as we destroy that wealth, as we waste that material, we are depriving our communities of that inherent embodied, there's that word embodied, that embodied wealth that's within those materials. So not only have we taken natural resources, put them into buildings that then we waste, but we waste the inherent value within those, whether they're cultural values through the history of our buildings, whether they're the material value itself, which I'll get to in a minute, or whether they're, you know, just irreplaceable materials that we can't mine anymore because they just don't exist. There's incredible wealth that needs to be reinvested into our communities. You know, I circle back to, you know, what happened to reduce, reuse, recycle. You know, reduce is of course the best option, but you know, we are living on this planet. We are in this world. The work that's being done by the circular economy folks and a lot of the architecture world now is trying to find out how we reduce our impact, and how we build buildings more efficiently so that we're not using as much raw materials. And that's great work. Recycling, as Mia just pointed out, recycling is a broad loop, and I love that slide. It really shows a lot. But it's a broad circle. Reuse narrows it down. Now, what about that reuse component in buildings? Why is this important? I think it's, again, going back to, I forgot to start my timer, Mia, so cut me off if need be. You know, going back to the communities and why it's important. Deconstruction, as you see here, is the systematic dismantling to preserve building materials for reuse. Where those materials go is the important part from a community point of view. Those materials come back into the community and they create jobs. Deconstruction creates 7 jobs for every 1 job in demolition. Those jobs are typically entry-level positions. A lot of the people that start in those jobs, like you see in this slide, can go on to other jobs within construction. I like to use the phrase that if you know how to take a building apart, that's a really good intro to putting a building together. We usually look at it the other way, but this group of folks here came to us, came to our trainings. They had no experience. They're taught how to take a building apart. By the time they get a couple years of experience, they can get work in other trades. So it's a very good entry level position. So job creation is a huge factor for a lot of communities. And when you're looking especially at blighted communities, as buildings are coming down and being destroyed, and that wasted material is being wasted, there could be 7 more jobs created for every 1 job tearing those buildings down, especially in blighted communities where there's underserved populations that need employment. It's a huge waste. Now, these kids will be working within their community to take those resources back into the community, typically into reuse centers. That's where most of the materials go. They also go to higher end material reuses, but a lot of the materials that get reused and into the system go through local community centers like this one. And it's unmeasured, the thousands of jobs that are created through that. The stores in Portland that I worked with had 70 employees working in 4 stores. And that's just one small city. The potential for creating reuse centers is immeasurable right now. The more buildings come down, the more materials are reused and focused through these reuse centers, the more jobs we can create, and to the benefit of our communities. The other advantage with those materials is that most of these reuse centers support needs-based people in the communities that are able to buy these materials at serious discounts to repair and rehabilitate their homes. So there's a huge benefit there as well. So what's up in our industry as we talk about deconstruction and reuse? It's amazing. When I started this work 15 years ago, the words were unheard. There was no conversations around it. Now we're talking with cities, and this is just a short list of the cities we're talking with now, but communities everywhere are starting to look at deconstruction and reuse as tools for community development within their city. Ways to address blight, ways to address economic gentrification, ways to address weatherization issues, different topics like that are being addressed through embracing deconstruction and reuse to get those materials and that material wealth back into the communities. We've got some challenges. I'll just spend a second here. We're a small industry. Where recycling was 25 years ago. We need to grow, we need to expand. The systems that allowed recycling to grow exponentially the way it did and with the speed in which it did was because it was able to still work on that linear model that Mia outlined earlier. Reuse is much tighter circular system, and it's going to require different systems. So as you look at that within your communities, within your businesses, you have to look at models and systems that will move larger amounts of larger materials. How we do that effectively is the key challenge to our industry right now. And last, here's our conference this year. It's going to be in Pittsburgh, October 28th through the 30th. If this interests you and you get juice on this subject, please come and join us. We'd love to see you. Thank you, everybody.
Thank you very much, Joe. And please let me introduce you now to Andrew Ellsworth. Andrew is founder and CEO of Doors and Hinge, the first U.S. company to exclusively sell reclaimed commercial doors, frames, and hardware. He leads all aspects of the company's strategy, develops partnerships, and analyzes new products and markets. Previously, Mr. Ellsworth has worked in sustainable enterprise development, green building consulting, and environmental health technical assistance. A self-described dumpster diver, Andrew is always looking to put waste to good use. Andrew?
Thank you, Victoria. Hi, everyone. Thanks so much for tuning in today, and good afternoon. I am in Pittsburgh, as it happens, home of we're hosting the Decon and Reuse conference this year. Very excited about that. I'm going to talk today about material reuse, looking specifically in the commercial area, and even more specifically within tenant and commercial interiors, not so much as the exterior buildings. So as Victoria mentioned, I run a company, Doors Unhinged. We reclaim and resell commercial doors. So we go into buildings, especially office space that's being renovated, and we take materials that would otherwise be thrown in the landfill. We categorize them, organize them, stack them, pack them, get them out to our warehouse. Then we sell them back to other commercial projects who are interested in the financial and carbon savings as a result. So looking at some of the data around construction and waste, construction and demolition waste is not the biggest stream, but it's pretty large. It's about 40% relative to municipal solid waste, around 170 million tons annually just in the US. If we dig into that a little closer, on the right-hand side, you see the commercial sector is actually making up the majority of this. Almost 70% of that C&D waste stream is coming from commercial. Demolition clearly is the biggest piece of that, but renovation is actually substantial in its own right. And so renovation is going to be materials that are coming out of buildings without the building coming down. So that's when an office space gets turned over and all the materials get taken out to the dumpster and tossed in a landfill. So that 32 million tons is, to us, our golden opportunity. Whereas something like corn shell waste often is going to consist of concrete, masonry, steel, brick, glass, what have you, some roofing maybe. Those items are really, in a lot of ways, better suited for recycling, just in the nature of being to take things apart and put them back together. I think there is some great reuse happening, and I love some of the slides that Mia was showing of systematically seeing structural steel being taken down. I think that's awesome. Sometimes these buildings are so old they can be obsolete. However, the tenant waste or commercial interior waste, however you want to look at it, is kind of a different story. These materials often come out after the build out could be as little as 3 or 5 years, but often around 15 years. Sometimes they're brand new. They tend to go into the building really as modular individual pieces, right? They're not necessarily highly customized, pretty standardized in their construction, how they're produced. And I would argue a lot of them, that materials are coming out are going to look a lot like the materials that are going into the next project. So what a great opportunity we have to really close this loop. To me, there's so much potential here, and this is why I launched a business in this space. To us, commercial material reuse is really taking materials out of commercial buildings and putting them back into commercial buildings. A lot of talk these days is about construction waste management and zero waste, and that's great, but it's not talking about where those materials end up. And so if they end up in some mixed recycling stream, I'm less fond of that, and I think there's a lot of benefit, as Mia and Joe have spoken to, about reusing those materials and tightening that circle in that loop. These are some common materials you would see in commercial interior projects. The majority of the waste is going to come out of drywall and steel studs, followed, I would say, by ceiling tile, carpeting, goes down the list. Door systems are in there. A lot of these materials, again, are highly reusable and, in my opinion, highly valuable. Looking at the carbon side of this, I first want to thank the Carbon Leadership Forum and all the people that helped out with doing some of their really formative studies. The benchmark study that looked at the whole building life cycle assessment and the carbon and embodied carbon within that. And then the subsequent studies for tenant interiors and for mechanical, electrical, and plumbing. This is great work, and we're kind of crunch this data a little bit. When a building is initially built, you're going to see that the majority of the embodied carbon is going to rest in the core and shell, and that makes a lot of sense. However, tenant spaces turn over much more regularly than this whole building one. And so over time, as your renovations happen, your carbon is starting to pile up. And naturally, so are the materials, right? We're tearing all those materials out, throwing in the landfill, getting new materials and bringing them in. So by the end of the lifetime, I mean, these numbers are very approximated in a lot of ways, but we're seeing that the interiors is actually providing, is a pretty stiff competition for the embodied carbon as compared to the core and shell. Looking at this another way, we took the data out of the Leadership Forum's tenant interior study and really wanted to understand how widespread certain materials were and trying to identify what the best candidates are for reuse if we wanted to maximize the embodied carbon we're capturing back. So what this chart is showing on the vertical axis, we're looking at any material's contribution to the overall project embodied carbon, right? What percent that material has of the total embodied carbon. And then along the x-axis on the bottom, that is that same material's contribution to the overall project mass. So we're essentially comparing how heavy something is relative to how much carbon it contributes. And so things that are low in mass and high in carbon, we would consider carbon dense. This may not be the best methodology, but this is the one we're working with right now. As you can see on the going up the left side, we have carpet as being really one of the highest. And then you drop down a little bit, you'll see doors, ceiling panels, glazing, and partition walls, which are the drywall and the steel is kind of over on the side. Then you look at all the little gray ones in the bottom, right down near zero, right? Those are all the materials that really are not contributing one way or the other. And if you look at a single environmental product declaration of one of those, you're going to see that it may have a high per unit contribution. But what was great about this study is that showed you how widespread that material is. So this has been the basis for how we're thinking about this. If we do go look at it pound for pound though, and go through various materials, I've still stuck with a lot of the same materials, and you understand my bent towards doors. So there are a lot of materials geared towards doors in here. If we compare that to a reclaimed material, pound for pound, reclaimed wins every single time, right? Over 99% reduction in embodied carbon, which makes sense, right? Because all we're doing is we're taking it out of the building, putting it on a truck, and sending it to a warehouse, hopefully not that far away. This is as we're comparing to essentially just the manufacturing process. If you're a life cycle person, that's LCA, stage A1 through A3. So there's huge carbon benefits from this. I mean, it's extraordinary. Joe mentioned, rightly so, all the great work that's happening in commercial reuse centers. We see a lot of that being based around the residential marketplace, where you have homeowners and artists and hobbyists that like to find a really great deal or something that's so special and unique that came out of a building that has a great story around it. That's fantastic stuff, right? And these centers often end up looking kind of like a Home Depot of reused materials, right? Really cool, interesting things you can wander through, throw some things in your cart, check out, and take it home. That's great. There's so many great centers around the country. We're seeing less work in the commercial space though. And part of that is the commercial reuse is going to look very different. We're going to see larger quantities of materials that are very similar. We don't really have that warehouse environment you come in and wander around. It's really more of a wholesale B2B business where we're working with contractors and architects and developers and maybe tenants to identify which materials can fit into their project. And similar to the way the industry works, material suppliers tend to be very focused. They're not Home Depots that are supplying drywall and doors and lighting and ceilings. Everyone is a different one. You have a door supplier, you have a lighting supplier, you have a flooring supplier, you have a ceiling supplier. They're very focused and they understand their industry really well. We see a huge amount of opportunity in the commercial reuse sector, which is why we launched Doors Unhinged. There's so much material out there. Again, that 32 million tons coming out every year, which has a lot of economic value still in it. Some of these materials, you wouldn't even know they're used, honestly. The other part of that is new materials going into commercial projects are expensive per square foot. They're much higher than residential. And why that's important is if you have an expensive material and then you're going to give someone a really good deal on it for buying it reclaimed, and you still have a reasonable margin to capture that material and essentially run a business around that. And that's the way that we can really get a lot of throughput, is because we have some decent margin. These materials, again, are going to be fairly similar. A lot of doors are 3 foot wide by 7 foot tall. Ceiling tiles come in 2 foot squares or 2 by 4. There's a lot of uniformity that's baked into this whole sector. So we can take advantage of that. Spaces, again, turn over very quickly, so there's a steady flow of material. And the room and also the need to specialize into specific areas or material types. Challenges, of course there are challenges. There are lots of them. Lots of material that can become a problem. I know firsthand, you open the tap a little bit and it can be like drinking from the fire hose sometimes. There's so much material that can come at you, it can be overwhelming. One of the largest challenges we deal with is working with architects and designers to incorporate reclaimed materials. And oftentimes they just don't necessarily want to move away from specific design they had and the very attachment that they may have to a specific finish, size, whatever. We're hoping that everyone can see the benefit of reuse and get to a level of pragmatism where we can get more of these materials into projects. Part of that may come from this goal of having the aesthetics of a space be highly, highly curated, and wanting things to be perfectly matched and look brand new, which in a lot of cases we are able to provide anyway, I believe. There's also people think that reclaimed materials are inferior. I personally don't believe that. I look at these materials and see them as highly valuable, but that's something we're going to have to work against. With all this flood of material, storage can become a real issue, as well as understanding your inventory and knowing what materials you have. I think is really, really important to being able to service your clients professionally and to be able to provide them the support and the customer service that they expect from their suppliers. Okay, so if we're going to get this to scale, how's this going to work? I believe that if we're going to really move a lot of materials, we have to set up very predictable and consistent processes that these materials can go through, right? It's like putting them through a machine. And that process has to be easy, and it has to reflect the way the industry works, right? It has to be able to deliver the right materials at the right time, the way materials are ordered, the way materials show up on the job site. You need to be able to work around that. I believe that the more materials that are available for reuse, the more likely we are to match what projects are looking for. After all, there's really only a finite number of finishes and types available. Yes, there's a little customization here and there, but in a lot of ways, we come over the same materials over and over again with maybe just minor variations to it. Personally, I believe that repurposing is not necessarily going to be a scalable solution. It's great to take a door and turn it into a desk. But if you're not doing that 1,000 times a month, we're not going to get to scale. Furthermore, you're going to take that door, you're never going to take that door, or that desk, I should say, and turn it back into a door, right? So we're kind of downcycling in a sense. All right, so using a little bit of math and that same information from the Carbon Leadership Forum TI study, some data out there says that there's about 400 million square feet of commercial office space built each year. That's interiors, right? That's not new, brand new ground up construction, right? So here's the ambitious goal I'm setting out. If we hit 50% of the square footage of that new space going in and have them use 50% reclaimed materials, what's the carbon impact of that? You go through all the conversions and the math, come out to almost 21 megatons of CO2 avoided by 2050. And that's just in the US, right? We don't have the ability, we know there's a huge amount of space globally, and looking in other areas, we don't have the capability to do those numbers. I'm sure someone can. If you know this, I would love to talk to you. So how are we gonna get there? How are we gonna hit 50% material reuse? Okay, well, this is, you look at this is what you consider pretty traditional circular economy, right? Instead of the linear approach, we're gonna close the loop here and capture those materials. I don't believe on its own this is gonna work, where you look from the people you get material from behind you and you sell to the materials to your customers in front of you. There needs more than that. And honestly, what we need is a central nervous system. Really a platform that allows the information to flow about what is where, what's coming out, who's involved, what's gonna happen, how much is it gonna cost. All this material really, and what I compare it to is essentially the multi-listing service that real estate brokers use for residential real estate. You have all these competing brokers that share in one central platform. The brokers are a key part of this. Imagine all these material reuse brokers that are working with this platform, working with individual customers, working with decon companies and reuse organizations to make sure you get this material flow that's as efficient and gets the right materials from the people who have materials to the people who are buying materials. And just think about all of the new enterprises that could pop up, that could build around this platform, all the jobs that are created. As Joe mentioned, how much more we get from a job in deconstruction than we do from a job in landfilling. So that's my pitch. Quickly in summary, there's so much material out there. There's legitimate and significant carbon benefits to it. It's a tough industry, but we just think we need to build the right enterprises that reflect how the industry works. And let's get ourselves together and organize the infrastructure to make this all happen. If you have any questions about any of the data I showed, or would just like to talk further, here's my contact information. Thank you so much for your time today.
Thank you very much, Andrew. And at last, we're gonna introduce Larry Strain. Larry is a founding principal at Siegel and Strain Architects. He is also the chair of the ECN Reuse Group. He has spoken on materials, sustainability, and embodied carbon at conferences throughout the country. He serves on the AIA Materials Knowledge Working Group and the boards of the Ecological Building Network and part of the Carbon Leadership Forum. Larry's publications include Resourceful Specifications, Early Guideline Specifications for Green Materials, a white paper named Time Value of Carbon Rebuilt is a chapter in the New Carbon Architecture, and the Total Carbon Study, which he was a co-author of it. For the last decade, he has focused on reducing the total carbon footprint of buildings and building reuse. Larry?
Right, thank you. So glad you're all here. This is a really important topic, and we've had some great presenters. I was really happy to get this group together. So you probably already knew even before this presentation that reusing a building and materials is inherently more sustainable than tearing them down and building new ones. But you've heard about the circular economy, built environment, and the need to think at multiple scales, which is really important. You've heard about a third of the buildings that will be demolished and the challenges and opportunities of the construction industry, and the particular challenges and opportunities of commercial interiors and why they matter more than we think they do, mostly because there's such high turnover in the commercial interiors market. And that the use and waste of materials has a huge impact on natural resources, on our communities, and carbon emissions. So I'm going to talk about this at the whole building scale and focus on carbon opportunities of reuse. So this is the way we currently think about getting to zero in the architecture profession. We think about building nice new net zero buildings. We're starting to think about reducing embodied emissions, and we're sort of thinking about reuse and upgrade, but not very seriously. And I think we have it backwards, and I'm going to tell you why. So let's start with new buildings. So this is a slide from 2030 that just sort of shows the impact over the next, between now and 2050, of embodied emissions, which are the yellow lines, and the operating emissions, which go up. Embodied emissions, if they happen the same amount, if we build the same amount every year, which is what we're projected to do, about 80% of emissions from new buildings will be embodied carbon. So when we're dealing with existing buildings, we really have to, with new buildings, we really need to be focusing on the embodied impacts. All right, so on an annual basis, it looks like this. New buildings, to build them is about 11% of our global emissions to build all those new buildings. To operate those new buildings is less than 1% of adding operating emissions each year for the new buildings. So embodied emissions are where we need to focus on with new construction. But there's another thing, which is that the existing buildings are sitting around emitting about 28% of our greenhouse gas emissions just from operating them all. So there's a couple of reasons we need to think about existing buildings. One is to not build so many new buildings by reusing more, and two is to try and make them more efficient. So I'm going to go off topic a little bit on this talk and talk about operational carbon as well, because I think they really tie together. On a global scale, there's huge opportunities. This is an interesting little chart that came out with the Global Status Report in 2017. On the left-hand side, the bars are all the buildings we already have in different parts of the world. And on the right-hand side are the buildings we're expected to build between now and 2060. The black bars are what we're going to build between now and 2030. And if you look at the three black bars that are the biggest, it's China, North America, and Europe. Those also happen to be, on the left-hand side, the bars where we have the most existing buildings. So to me, there's this huge opportunity to say, if we could reuse more of the buildings in those countries, we could maybe build fewer new buildings, and both those numbers then come down. We're avoiding embodied emissions by building fewer, and we're upgrading our existing buildings and lowering the carbon of that. And this quote at the bottom was basically, this report is saying we have to go to deep energy retrofits of existing buildings, has to be part of our strategy. So these things tie together over and over again. This embodied carbon and operational carbon, really existing buildings is where the huge opportunities are. Here's a little chart on how it breaks down, how embodied carbon breaks down. So large, heavy buildings, something like 100 pounds a square foot to build a new building. A lot of that's because the larger building, commercial buildings, tend to use more carbon intensive materials. They're also very heavy buildings. Small, light buildings, wood frame buildings might be half that. But the real savings is when you get into renovating existing buildings, you're going to spend less than a quarter of that typically, because you're not dealing with the foundations and the structural system. You're dealing with interiors, MEP systems, and you're basically taking a building and putting much less investment into embodied carbon. So it's much lower. So this is a little study we did a few years back on the DPR offices. This is a net zero remodel for DPR. This is not our project. We just did the study. But this is a quick example of different savings from this project. So this is the embodied emissions per assembly. And you can see the hatched lines are the materials that didn't come out of the building. They stayed in the building, and the solid bars are all the materials they put into the remodel. And it resulted in about a 70% reduction in CO2 emissions by reusing the building and investing a little bit in the remodel. What this didn't initially do, it didn't count the PVs and the MEP systems, because Tally at that point didn't have that in their database. So we estimated those on our own, and what that did was it about doubled our embodied carbon footprint for this remodel. The good news was that those PVs will pay for their carbon debt in about 4 years by making it net zero. So here's an interesting thing about where the opportunity lies. So energy upgrades were actually the biggest upgrade, but so it looks like reuse doesn't make that much difference, but it was 650 tons we saved over building a new building by reusing the building, and that happened in the first year. That all those savings happened when we opened the doors. We'd already achieved those. The energy upgrades happen over 20 years. So we really have to, the bottom line to this slide is that we have to do both we have to save embodied carbon, and we have to save operational carbon. And if we reuse buildings without doing the energy upgrades, we're missing this huge opportunity. So I did these little charts that basically show this graphically. So if you look at the chart on the left, it's basically showing embodied and operating carbon for new building options. There's a new efficient option, a new all-electric building, and a new net zero building. And when you get down to a new net zero building, all the emissions are in embodied emissions. And you can see you get down to 137 tons to build that building. If you just left the existing building as it was, you're emitting 200 tons of operational carbon over 10 years. But if you look at the retrofit options, the embodied carbon comes down, and you're taking it to 50% less emissions by making it 50% more efficient. You've cut those emissions in half over 10 years. If you get to net zero, you cut 200 tons out. So on the right-hand side, you can see the cumulative. When you add these two together, you can go from just building a new efficient building is going to be worse than leaving the existing buildings as it was, all the way down to a retrofit to net zero. You're saving 150 tons of carbon by reusing and retrofitting that building. So there's opportunities both from embodied carbon and from operational carbon. This is a lightweight wood building. If you look at a heavy building, it's the same kind of curve, but the numbers are much bigger. So the potential for savings is now 1,250 metric tons, because the operational energy and the embodied carbon is so much greater. So you just much bigger savings. This is a 50,000 square foot concrete or steel building. The other one was a 5,000 square foot wood building. So there's a huge opportunity to retrofit and to reuse, and we have to start doing it all. So reusing and upgrading accomplishes two things. We lower embodied carbon by reusing the building compared to building a new one, and we lower operating carbon by taking an existing inefficient building and making it way more efficient. This is the Wendell Wyatt Federal Building in Portland, built in 1960. We gave this a AIA Coat Top 10 award a few years ago when I was on the jury. They took this building and they replaced the concrete cladding with a new skin, which I would question normally. But what that did was it made the building so much lighter that they didn't have to do a seismic upgrade to the building. The existing structural frame now works because the building's much lighter. They provided shade and glare control. They improved daylighting, lowered energy loads, and it allowed the building to upgrade to radiant heating and cooling, which improved occupant comfort. It uses 55% less energy than the existing building did, and it freed up 31,000 square feet of rentable space that was dedicated to mechanical floors that now went away. So it was an amazing retrofit and remodel of an large existing building, saved them a lot of things. They did not do an embodied carbon analysis of the project, which would have been very instructive, but I still think they probably made a very good choice. So basically, I think our priorities are backwards. We need to start by reusing and upgrading, and I'm going to put upgrading in all my reuse ideas from now on, because that's doubling your opportunity. We also need to reduce embodied emissions, and we need to build new net zero buildings. All our new buildings should be net zero, but we've got the priorities backwards. This is a little this picture of a commercial space in Silicon Valley that was retrofitted to net zero. There's a company called Sharp Development that's doing these incredible projects where they're taking small, not very nice buildings and turning them into Class A net zero office space and making money at it. So that's the end. I'm going to stop there, and hopefully we got time for some questions. Let's see.
Thank you very much, Larry. And please use the chat function on your Zoom and send questions away. We have now like about 10 to 15 minutes of questions, so please feel free to send. And while we wait, that right now there's no questions, I kind of have a question for you all. Like, how would you incentivize, or what would you tell to all the people right now listening to us, and how can we do, what can we do locally? What can we start doing, like one person at a time?
Well, I'll jump in first, which is that I think we all should be doing one person at a time solutions, but I think that the actual solution is much, one person at a time doesn't really matter. So we have to start, as Andrew mentioned, and everyone talked about, developing larger systems that make this viable. We have to scale this somehow. And the reuse centers are great, and they've been around for a long time, and they mostly serve, they primarily serve residential people, and they work pretty well. They need to be scaled up, and then at the commercial scale, there's a whole different set of you have to, it's much more modular, and it's much more regularized, and it's much more high volume. There's a whole new system that has to be set up to do this at a commercial scale. So I think Andrew's onto something about really trying to find a way to scale the commercial amount of TI work that happens every year, which is just, and it's not because things wear out, it's because people come in, they want a new look. Anybody else have anything to add to that?
I'll jump in. This is Mia. I think it depends on who you are, what role you're playing in the building sector. We focus on local governments. So if you're a local government employee working on deconstruction policies, working on credits, green building credits that require salvaged and reused materials, those would be kind of systemic ways to get more of that to happen from that role. Others could probably talk about other roles.
This is Andrew, if I can jump in. I would say the number one thing we can do is to actually build demand for reuse. That doesn't, I guess that sort of applies to what Larry was talking about, whole building reuse, but we got to have a commitment to that. I mean, we can do deconstruction and construction waste management all day long, but if no one's buying the materials, the system just falls apart, right? So the thing that people can do is to start asking their local deconstructors if they can find the materials they're looking for. I mean, put it out there. It may be a little hard to start, but the idea is if we get this train moving, we can start to pick up some momentum and learn a lot and figure out these things as we go. So to me, it's kind of a partnership in that regard.
So Andrew, so there's a follow-up question. Sorry, Larry, and you can jump in because this will be also related to maybe your answer, Larry. So there's a question about what do we tell teams then that think building reuse is prohibited from a cost and a scheduling perspective?
If I can address that one, I'd tell them that the way they're measuring that cost needs to be challenged. Are we talking short-term cost or long-term cost? Because the long-term cost of building the way we're building now and thinking the way we're thinking now is astronomical. We just don't cost things correctly to take the true cost into into the fact. We don't factor in the true cost.
Yeah, and for commercial, I would say that probably the biggest issue from my experience doing commercial work is that the schedule is more of a barrier than the cost. For the contractor, for the architect, it may be appearance, or they can't just go online to a catalog and say that's the ceiling tile I want. If there were a way to do that, if it were that simple to specify an existing material, there's no reason people wouldn't specify reused ceiling tiles, because they're just ceiling tiles. I mean, so, but I do think that scheduling, you've got to get a delivery system that's fast enough to fit in with the commercial market. So I think it can be done, because people order their materials months in advance a lot of times for a large commercial project. So you can spend some time assembling it, but you can't wait till the last minute currently and then expect to find everything exactly like you want it.
Yeah, what I was going to say to the first question, this is Joe again, what I was going to say to the first question is that people have to be asking for reuse. They have to be asking for the materials up front. It's almost impossible for a contractor to be the point person to introduce reuse. It's a little easier for a designer. When the owners, when the developers, when the people who initiate projects are the ones that request it, and this can happen on a small scale. You're renovating your bathroom all the way up to, a 100-story office building. Scale doesn't matter. It's requesting at the earliest stages that reuse be incorporated. I think that's the biggest thing that'll make a shift.
Thank you, Joe. So there's another question I think might be good for all of you. What are the regulatory and liability constraints on reuse, remake, etc.?
Well, I'll give you one about structural lumber. Oregon was looking for code, rewrote the code within the state for building with used lumber. And the way the code was written, it was very, very negative. It was kind of allowed, but very discretionary by the code officer, and it was rewritten by some folks in the panel to say, well, reuse of materials is allowed unless it doesn't meet the requirements of regular wood. So that changed the game in Oregon as far as the reuse of lumber in new built environments. And there are probably other examples of that, but that's one small change that could create a huge effect nationwide if it's made.
Can I jump in? This is Andrew. Regarding the liability issue, I hear that a lot in some ways, but I think some of that is lawyer paranoia about, like, oh, what if something goes wrong with this reused thing that we bought or installed in our building, even though it was only 3 years old. Whereas I don't see anyone saying that you have a big liability to move into a building that's 15 years old, right? I just think there's a little bit of a paranoia about what could be, and I don't know. I think we're gonna have to push through that. I would love to see, real examples of if that's really happened, because I don't think it is.
Yeah, if it gets to be a big enough network, it may be that the reuse network can start to offer some sort of warranties on products in the same way that new materials do. You'd have to pay a premium a little bit to get the warranty, but I don't see why someone putting in essentially a brand new door wouldn't, if they got extra money for the door, wouldn't be willing to offer a small warranty. So I think that commercial owners, more than residential owners, even want warranties on products. That's how it's baked into their insurance and all kinds of things. So we may have to face that somehow. I don't think most of these materials are any more likely to fail than a new material.
Yeah, I'll build on that about the warranty issue. Colleagues of mine tried to do a commercial reuse warehouse and the warranty was the main issue. I think it's also chicken and egg. Like there's not enough demand for this, for people to spend time on creating new warranties for reused products.
Right, right.
Thank you all. This question is for Andrew. Do you have, when you sell all your salvage doors, do you have a kind of like a buyback or program that if the customers want to do another remodel and they don't want the door anymore, will you take it back, or how does that work?
It hasn't come up yet, I would say. We've only been in business about 1.5 years, but to me, we don't buy anything. we receive. So I would probably take back doors, and I would love that actually, to see those go back to another space, because I think these end up being highly reusable. So the answer is sure. I'm waiting for the first one to come ask me. So
great. There's a question maybe for Larry. Well, there have been a lot of talk about operational carbon for the last 25 years, but what really needs to be done to take this to the next level to maximize the carbon reduction in general? I think you have some slides that they were showing some
Yeah,
what needs to be done.
Well, what was interesting about doing that study for the DPR office building was this was a 2-story, 20,000 square foot commercial office building in San Francisco that didn't even have great orientation on its roof. It got to net zero and beyond, net positive actually, on a standard construction budget. And so I just think that there's this huge, I think that our goals for energy efficiency, especially for existing building retrofits, are too low. They're typically improve it by 20% or improve it by 10%. We have to be aiming for 50% to net zero on our improvements. I mean, and there's a lot of work that Rocky Mountain Institute has done on this, and they actually have looked at the times you insert into a building. If you're a building owner that owns lots of properties, you sort of categorize all your equipment and when it's likely to be replaced, and instead of just replacing it or replacing with a slightly more efficient, you jump up to way more efficient. So figuring out the ways to jump to far more efficient systems, and then at the end adding PVs. I just think we have to set our goals higher for this. Retrofit programs have been around for a long time. A lot of them have focused on residential retrofits and incentives, and I think we have to get more aggressive on what our goals are. Most of the country, 1 to 3 story buildings have enough roof area and the potential to go net zero. And 1 to 3 story buildings make up a huge proportion of our commercial and residential space in the whole country. So I just think we have to sort of step back and say, all those existing emissions from building operations, that's all from existing buildings. That's, the 28% of our total global emissions is from existing buildings. So let's get serious about our goals and not just talk about 10% reductions every 5 years or something like that. So I don't know how. I think that has to be, it's harder because how do you bake it into the code? The code for new buildings is you have to meet certain energy codes. We have to start identifying places you can insert in a system where an existing building owner will have some requirements and or incentives to upgrade their building every so often. We have to find a way to make that or to finance that so that will happen. Because right now there's nothing that makes an existing building upgrade their building.
Cities have tried to do existing building requirements, and they've encountered so much opposition.
Right.
But we're continuing to try it. But yeah, you're right. Those are kind of incremental. They're talking about 15% savings when we really need to talk about deeper decarbonization.
Yeah, there's a few cities that are trying this, that are finding ways to have more places where they can require existing building owners to upgrade their building. And one of the first steps is in New York City, where they're just requiring existing buildings over a certain size to publish their energy results. So there's sort of a public shaming, maybe, if you, just to sort of, if you're picking a new space and you can say, well, this space is twice as efficient as that space, and if I have the choice, I'll pick the lower carbon space, just to be able to say that in my marketing or whatever. So I think there's ways to make this happen. I think it's going to take some incentives, and I think it's going to take some investment. I think the government and regulatory agencies are going to have to be involved. We can't leave it all to the building owners.
Great, thank you all. There's a kind of a combined two questions. So what type of building materials can be reused or salvaged, and what to do with others that they cannot be reused or salvaged because they don't meet code, the life expectancy has ended. How, like, for example, there's example here about toilets, and they have heard that you can maybe crush them and use them for habitat for fish and sea life. So are there resources out there of what can be done to certain products or materials?
You probably have this one, Mia. I mean, there are lots of resources. Stop Waste probably has a lot of them, but I would generally say, just and then I'll let someone else jump in, that reusing a building a product that has a performance component to it, like a low flow toilet or a insulated window, that you don't want to reuse a product that's poor performing and reuse it again. That's the one case where I would say deconstruct it, recycle it, do something else with it, but don't put it back in a building and continue to waste energy or water. It doesn't make any sense.
Anybody else want to jump in with that?
I'll talk about lumber a little bit on that respect. The challenge with lumber are what we call shorts. Anything under 4 to 6 feet is very, very challenging to try to reuse. Same with 2x4s in general. Larger dimension stuff, very easy to find new homes for. The smaller stuff, almost impossible. One of the things that Tallwood Design at the University of Oregon is looking at is, or it might be State of Oregon. One of them is looking at using salvaged lumber in cross-laminate timber construction. So that's a new and emerging opportunity there. Now it's not exactly reuse, but one of the things we have to look at as we build the reuse culture is there's always going to be those elements, those that can't be reused in their original purpose and will need to be upcycled or downgraded one way or another. What's the highest and best way to do that is the question. But right now we're talking, when an entire building is thrown away, when we could find an easy reuse for 60% of it, we're not anywhere near that. If we can just go for the low-hanging fruit, so to speak, as a start, we'll be way ahead of the game.
Great, thank you. So we're running out of time. Some other people have posted resources and other information about codes that they are being placed in different areas around the country. So please feel free to check those resources. One person asked about the slides. Yes, they will be available by October 11th. They will be posted in the ECN website under the webinars, and also the webinar recording will be available October 11th. Thank you very much all for taking all the time to speak about what you're doing, Mia, Joe, Andrew, and Larry. And to all of you, this concludes the webinar for today. Thank you for joining. And if you have any questions or comments, please send them to info@embodiedcarbonnetwork.org. And if you have not joined the Embodied Carbon Network yet, sign up today at embodiedcarbonnetwork.org. You all have a great day. Thank you very much.
Thanks, everyone.
Thank you all.
Thank you all.
Thank you.